Okay, what Christine is going to do is to have a little bit of copper 2 sulfate solution, which is what color? Blue. And we are going to add sodium hydroxide excess into here and see what's the final color of the solution. Okay, final color of the solution. All right. Okay, that's almost half a test tube full. Okay. Now, although it is very difficult to see, it's very difficult to see, what do you think is the color? We see what? We see a
dark blue.
Wow, we see a blue PPT, right? No? We see a blue PPT. And this blue PPT, if I filter it out, then you will be stuck on the filter paper. But what do you think will be the color of the solution? What do you think will be the color of the solution?
White?
Yeah, it will be colorless. Okay? So which means that maybe, hold this, based on our balance equation, our balance equation is 1 mole of copper 2 sulfate reacts with 2 moles of sodium hydroxide. Then that is the exact number of moles for the balance equation there. Okay? Then the final thing is you get a blue PPT with a colorless solution. Okay? So although the PPT is suspended in the colorless solution of sodium sulfate, finally there is no blue color in the solution. The blue color has been extracted out as the insoluble copper 2 hydroxide, which is Cu bracket OH bracket 2. Alright? So this is what is important. So the amount of copper 2 hydroxide depends on how much copper sulfate we have. Although the sodium hydroxide was added in excess. Okay? So the sodium hydroxide was added in excess, alright? So this is in limited amount. Copper 2 sulfate is in limited amount. So the limited amount determines how much copper 2 hydroxide we will get. Is that clear? I can add the whole excess, whole tub of this, but the precipitate will only depend on the limited amount of copper 2 sulfate. So this one is what we call in chemistry limiting reagent. The limiting reagent limits the copper 2 hydroxide. Now that is common sense, right? No? If I have a lot of this and very little this, I get very little copper 2 hydroxide. That's all. So this is known as the limiting reagent. Now that's a very important concept. Okay. What we want to do now, we will do another limiting reagent. We take a little bit of, you can put it there. We take a little bit of iron 2 sulfate. We take a little bit of iron 2 sulfate. Okay, dissolve in water. Dissolve in water. Good. Yeah. Well, that's a lot. Never mind. Check. Yeah. Okay. And this time we are going to, this is a little bit, what color? Green, huh? It's a little bit greenish, right? Huh? Light green, huh? Very light green. Now there's only very little amount of iron 2 sulfate, okay? Now I'm going to add excess sodium hydroxide. See what you get. What's the PPT? Oh, the PPT is dirty green precipitate. Again, if the iron 2 sulfate is limited amount, you have excess sodium hydroxide. Again, the iron 2 sulfate in limited amount is known as the limiting reagent. Okay? And no matter how much sodium hydroxide I put, the amount of iron 2 hydroxide will be limited by the amount of iron 2 sulfate there is, okay? And if we let this settle, you will find that ultimately the solution will be colorless like this. Actually, this is a little bit colorless, right? If I put some more. Is it colorless now?
Yeah.
Yeah, almost. Huh? Almost colorless. Almost colorless. Okay. So in exam questions, they will ask you, if I have limited amount of copper 2 sulfate or iron 2 sulfate and excess sodium hydroxide, what will you see? You will see the color of the precipitate. One is copper 2 hydroxide, the other is iron 2 hydroxide. And then the solution left behind will be colorless. Is that clear? Because the iron 2 sulfate and the copper 2 sulfate are in limited amount, and we label them, we say that they are the limiting reagent. Yes? Good. Yeah. So that is actually some calculations that you need to do to calculate the amount of the precipitate that can come out. Okay? Yes.